Okay, so this is the last thing that we're going to talk about in preparation for the quiz. So I'm going to ask you to write down what's in underlined and bolded right here, just the sentence right there. But there's no traditional definition, so you have to write down. Okay, so just imagine that this is your definition. So, what causes the global movement of water? Sunlight and gravity. They are what cause the global movement of water. So, sunlight causes water to move upwards in the form of evaporation or transpiration. So, because the sun causes these things to become lighter, they turn the water into a gas. The gas is less dense in the surrounding air, so it rises upwards. So, that's the only reason that you're getting any movement upwards. It all has to do with density, it becomes less dense than everything else around it. Now, water falls down, right, because of gravity. That's precipitation. Precipitation comes down in many ways, right? So sleet and hail, we know that. So try to think of other ways that gravity is involved with the global movement of water. Well, runoff, right? Moving from side to side, right? And it's always moving on a downward slope, so that's being pulled by gravity. You also have infiltration moving into the ground. You also have percolation moving down through those open pore spaces. So anytime you're thinking of anytime it's moving, it's because of either sunlight or gravity. And here's a fun little water cycle slide right here showing the sun pulling the raindrops up to the top into the cloud, and it shoots back down. So you have your little evaporation, condensation, and precipitation taking place right there. Now, how do the global ocean currents work? So you don't need to write all this. There's a lot of information here, okay? You do need to know the part that's in bold. So I'm going to leave it up to you. Do you want to write this down? That's your prerogative, your choice right here. Otherwise, just pay attention. Differences in weather have to do with global ocean currents. So you can't really see right here, but this is normally a moving GIF, and all of these things are constantly moving around. The warm water, and that's represented by the red arrows right here, is constantly moving towards where it's colder. So the warm air, water right here near the equator, it's going to be warmer because it's getting the most amount of direct sunlight. We learned about that in the astronomy unit. Most of our direct sunlight is at the equator. When it heats up, it's less dense, so it's going to basically rise up, and that could be up to both poles. So it's going to go to the South Pole, it's going to go up to the North Pole. When it gets up there, it becomes colder because it's a lot less sunlight there. So during that time, it becomes a lot colder, the water. It becomes heavier, denser, and that's what causes it to sink back down. And when it sinks back down, it then sinks all the way back towards the equator, where at the equator, it rises up again. So I don't know if this sounds familiar to you, but this process of it rising and falling like that due to heat is called convection. And we've learned about this in another unit. So I'd like for you to think about what unit that has to do with. The one that comes to mind for me is when we talk about magma currents and the rising and falling of the magma inside of the mantle. All right. There's an awesome video here. It's a little bit long, but it talks about the Gulf Stream and like why we have this global ocean current system. And it kind of talks about like what could happen if it stops working at some point, which is pretty cool. So this is a note for you, okay? Everything beyond this is stuff that will help you understand the big picture of things, but it's not going to be specifically covered on the water quiz. So none of these things after this, you don't have to write it down. Okay, I'm going to repeat that. You do not need to write anything down past this, but I think watching it will still help you. So let's talk about it a little bit. We talked about the different layers of the water. So as you get further down into the water, the temperature drops, and it drops off very quickly. So here's the surface zone, right? It's the warmest top layer of the ocean that's up here. And then right around this time, it's called the thermocline. Think thermo means heat. There's a drastic decrease in heat. Notice if this is water temperature right over here at the bottom, 0 would be freezing. It never quite gets to freezing. Even though it's really cold at the bottom of the ocean, it's not freezing cold, but it is really, really, really cold. It's approaching that, but obviously it would be frozen if it was, and it wouldn't be water at that point anymore. It would be ice. So at the surface zone, around this time is when the amount of sunlight starts to drastically decrease. So the sunlight cannot penetrate all the way through there. And the sunlight starts to basically dry up in a way, and less of it starts to happen right here. So the temperature starts to decrease very rapidly as you get further down into the deep water zones here. And then down over here, deep zone is where it's going to be really, really cold. So this thermocline right here is this layer where it starts to get a lot colder. So the denser, colder water is at the bottom. Remember, colder water is denser than the warmer water at the top. And then here's that thermocline that it's called, a zone where that happens. The other thing that changes the density of it is the amount of salt. So it's also going to be saltier in general. Saltier water just has more stuff in it, so it becomes more dense. And then if you talk about to desalinate water, if you wanted to take the process of take the salt out of the water, it is possible to do that. You can just do that naturally. You could take a cup of salt water and just leave it outside. And eventually, over time, as long as nothing happens to that cup, it doesn't get knocked over, nobody comes over and drinks it accidentally, anything like that, the water will evaporate. And what's left behind is just the salt that's left over. So that's how you desalinate something. Now, it sounds really simple in theory, but it's actually to do this on a massive scale. Like if we were to say, okay, we're going to run out of water, let's say we want to purify salt water and turn it into drinkable water, that's more difficult than it seems. It is so energy intensive that basically it's just not economically feasible right now to do that. So it doesn't make a lot of sense. Nobody's investing a lot of money into doing this. Now, it could be a great idea to do that. There has to be new technology to make it cheaper and easier to do. And so far, that technology does not exist. But in theory, you can certainly do it. You just have to apply energy to it, right? And you can extract the salt and minerals from the water and have fresh water that's left over. Salt water is very abundant, right? And not a lot of use for it other than certain types of fish that live in the ocean, they like it there, sure. But for us, we might want to extract the salt and the minerals. We want to have the fresh water. That's valuable to us. But again, it's incredibly energy intensive. And it's just not a practical way in any mode right now. We're not anywhere close to that. But maybe some kind of energy revolution in the future could help with that. And I have one final video right here that talks about how deep is the ocean. It's a really cool video. So that's it, guys. Thank you.